anionic vacancy which are occupied by what? Unpaired of electron. It is said to be F center. You need to write the 3 steps to show that how the number of particles will be distributed in a simple cube, BCC as well as in a FCC. If they ask you to write the differences between any two solid, remember always put a column and make the 2 parts and write crystalline and amorphous. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, we are going to do the revision of the second PUC Chemistry. Okay? So first I'll go with the first unit, the solid state. So before going to discuss with this unit, let's see the weightage of this unit. So already all of you know that in this time, due to COVID, we got a lot of choices for writing the answers on your second PUC exams. And there will be a lot of questions from the each part. That is from the part A, part B, part C and in the part D. According to that, the weightage of the each unit which has been changed this time. So we'll see how does the each unit and the weightage will be distributed. Okay. First I'll go with the first unit weightage, that is in a part A we can expect the first question from this unit, that is from the solid state. So in a part A the question number 1 will come from this unit. Even in a part B the question number 16 will come from this unit. So hope you know that in a part A there are 15 questions will be there. In that you need to attend only 10. Okay. Like that in a part D we can expect one more question, that is question number 36. Okay. That is in the 5th main we can expect the 5-mark question and that comes from the solid state, and totally we can expect 8 marks from this unit. Okay. So how many marks will be allotted for the solid state? So the 8 marks will be allotted from the solid state. We'll see which are the important questions can be asked in a part A, part B as well as in the part D. Okay. So in the part A, we are going to discuss with a 1-mark question. So how the questions will be framed and what type of the questions will be asked from this unit we'll discuss first. Later on, we'll shift towards the 2-mark questions also, and later we'll see with the 3-mark that comes under the 5-mark question. Because in your chemistry, hope you know that in the 5-mark, always it will be 3 plus 2 or 2 plus 2 plus 1, or it may be 2 plus 3 also, or it may be 1 plus 1 plus 1 plus 1. Okay. So that is why you must know that there will be a splitting in the 5-mark question. That is why I have put it as a 3-mark question. Okay. We'll see with the 1-mark question. The questions will be goes like this. Define coordination number of a particle in a solid. So this is the most repeatedly asked question in your second PUC chemistry. Is it right? Yes. So what is the coordination number? It is nothing but a total number of nearest neighboring particles to the given particle. It is known as what? Coordination number. It is a total number of nearest neighboring particle to a given particle. And next question will be, what are F center? So hope you know that the F center which we have studied in the imperfections in the solid part. Correct, no? Yes, it is a anionic site which has been occupied by unpaired of electrons. The anionic vacancy which are occupied by what? Unpaired of electron. It is said to be F center, and hope you know that these 2 questions which we have asked repeatedly in your midterm as well as in the board preparatory exam. Even in a board preparatory exam, they have asked what is F center. Correct, no? So this is a important 1 mark question. Coming into the next question, name the type of non-stereometric defect which is observed when white zinc oxide which turns into yellow upon heating. So here you need to tell the defect name. So already we know that it is nothing but a metal excess defect. Coming into the next question, which defect it is also known as dislocation defect? Which defect is known as what? Dislocation defect. It is nothing but a Frankel defect. Correct, no? It is nothing but a dislocation of cations and anions from the normal sides. That is known as what? Dislocation defect, or it is known as what? Frankel defect. Next question is, what is doping? Doping is a process of increasing the conductivity of an intrinsic semiconductor by adding suitable impurities. So what is a doping? In order to improve the conductivity of the semiconductor, we add some of the impurities. Such process we call it as what? Doping. So these are the important questions which come from the first unit, the solid state. We'll continue with some more important question in the part A. What are the types of semiconductors which has been obtained when silicon is doped with boron impurity? So again it is nothing but a P type of semiconductor. What is the color which has been imparted to the sodium chloride crystal due to the presence of excess of sodium? The color of sodium chloride crystal is yellow. Even though the sodium is present in the excess quantity, it gives rise to the yellow color. Name the crystal defects which lowers the density of an ionic crystal. Which defects which lowers the density of an ionic crystal? Obviously, it is a Schottky defect. Whereas in the Frankel defect, there will be no change in the density. Hope you know while writing the differences. Okay. When a solid is cut with a sharp edge tool, they cut into two pieces and newly generated surface are plain and smooth. Identify the types of the solid. It is nothing but a crystalline solid. Okay. Which types of force of attraction is present between the molecules in polar molecular solid? So it is a dipole-dipole interaction. So these are the type of questions and also most repeated questions which has been frequently asked in your first unit, the solid state, especially in the part A. Okay. We'll see with the 2 mark question. Okay. We'll see how to write the answers and how many points we have to write if they ask you to write for 2 marks. We'll see now. The questions will be goes like this. Write the differences between crystalline and amorphous solid. If they ask you to write the differences between any two solid, remember always put a column and make the 2 parts and write crystalline and amorphous. It has been asked for 2 marks. Write only the 2 proper differences. So it is very easy to get a 2 mark. No need of writing for 4 to 5 differences. Any 2 differences, it's enough to get a 2 mark. Okay. So it is also known as what? True solid, whereas amorphous solids are also known as what? Pseudo solids. Okay. It has a definite geometric shape. It has no definite geometric shape and usually it is irregular in shape. And also it has a long range of order. They have a very short range of order and they have a sharp melting point and they gradually soften over the range of temperature. Remember, any 2 proper differences if you write, for writing for 2 mark, it's enough to get a 2 mark. Okay. Next is differences between Frankel and Schottky defect. Again, here, if they ask you to write the differences, any 2 proper differences, it's enough to get a 2 marks. Okay. So Frankel defects means it is an ions which has been occupied on the interstitial position than that of the actual lattice position. Whereas in the Schottky defects, you can say that it is a missing of equal number of cations and anions from the lattice position in the crystal lattice. And the density remains same in the Frankel defect, whereas in the Schottky defect, it will be decreases. So, any two differences, or you can write any one of the examples to differentiate between Frankel and Schottky. That is also enough to get a 2 marks. Okay. Next is, what is ferromagnetic substances? Given example. Okay. The substances which are strongly attracted by the magnetic field, they are called as ferromagnetic substances, and a phenomena which is known as what? Ferromagnetism. Examples are iron, cobalt, nickel, etc. For writing the correct statement, you will get a 1 mark, and writing the example, you will get a 1 mark. Okay. So, no need of worrying about the diagram. Just have posted this diagram for the reference. Okay. So, just write the proper statement along with the correct examples. Okay. Next is, what is ferrimagnetic substances? Given example. The substances which have unpaired of electron and also have a domains like ferromagnetic substances, but they are weakly attracted by the magnetic field. They are known as what? Ferrimagnetic substances, and the phenomena which is known as what? Ferrimagnetism. Okay. Examples are magnetite, that is Fe3O4, and ferrites like MgFe2O4 and ZnFe2O4. So, here you need to understand that in the 2 mark, either we can expect one differences, either we can expect the question from the magnetic field, either it may be diamagnetic, paramagnetic, ferrimagnetic or ferromagnetic substances. And also we can expect the question from the density part, that is we can expect one numericals also. Okay. We will see how to solve the density problem. Okay. An element which are having atomic mass of 60 has a face-centered cubic unit cell. The edge length of the unit cell is 400 picometer. Find its density of the unit cell. Again, here you need to calculate what? Density of the unit cell. First, write the formula for calculating the density, that is D is equal to Z into M divided by A cube into Na. Okay. So, here they have not given the Z value, but they have indicated that it is a face-centered cubic unit cell. So, in the face-centered cubic unit cell, number of particle is 4. Correct, no? And coming into their atomic mass, so they have given us 60. Okay. Coming into the edge length, they have given the A, that is 400 picometer. We know that 1 picometer, which is equal to 10 to the power of minus 10 centimeter. Then what will happen to the 400 picometer? It will become 400 into 10 to the power of minus 10 centimeter. And we know that what is the value for Avogadro constant? It is nothing but a 6.023 into 10 to the power of 23 atoms per mole. Correct, no? Now you substitute the values in the above formula, that is 4 into 60 divided by 400 into 10 to the power of minus 10 into whole cube, because it is a cube. Okay, into 6.023 into 10 to the power of 23 atoms per mole. Now, if you solve these two, you will get 6.226 gram per centimeter cube. Gram per centimeter cube. This is a density value. Okay. This is how if you write the formula and if you substitute to the formula and if you write the correct answer, you will get a 2 mark. Okay. If you write only the formula, you will get a 1 mark. And for writing the substitution and writing the correct answers, you will get a 1 more marks. Okay. This is how you need to attend the question from the part B, either in the part D. Okay. Next, we have one more problem. We'll see how to solve it. The silver forms CCP lattice and X-ray studies of its crystals shows that the edge length of the unit cell is 408.6 picometer. Calculate the density of the silver. Again here, so they have given the values of the A, that is 408.6 picometer. We know that 1 picometer, which is equal to 10 to the power of minus 10 centimeter. So I can rewrite the A value as 408.6 into 10 to the power of minus 10 centimeter. Or if you wanted to shift the zeros, you can make it as 4.086 into 10 to the power of minus 8 centimeter. Okay. I am simplifying the values. Coming into the CCP means what? It is a face-centered cubic unit cell. We know that in the face-centered cubic unit cell, number of particle is 4, and also they have given the mass. What is the mass? It is 107.94. Okay. And what is the Na value? Avogadro number, it is a constant value, right? It is a 6.023 into 10 to the power of 23 atoms per mole. Now, you write the formula, that is D is equal to Z into M divided by A cube into Na. So, what is the value? It is 4 into 107.94 divided by A cube is 4.086 into 10 to the power of minus 8 whole cube into 6.023 into 10 to the power of 23. Okay. Now, if you solve these, okay, you will get 10.558 gram per centimeter cube. So, this is a density value. This is how you need to answer the question for the 2 marks. It is very simple to attend the density numerical. Just read out the question twice. See that whether they have given the Z value or if they have given the hint like VCC, FCC or with a simple cube, you need to put the values for Z, and also they will give the M value, and you need to know the Na value, that is Avogadro number, and also they will give the edge length. So, just substitute to the formula and get the 2 marks easily. We'll see with the some more 2 mark question. Okay. Calculation of number of atom per unit cell in the primitive cubic unit cell. So, in the primitive cubic unit cell, whereas in the BCC, whereas in the FCC, it is very important to know the calculation of number of particle, and it is very easy to get a 2 marks from this part. Okay, I'll tell you how to write with a simple cube. So, this is a simple cube where each corner particle will contribute how many particles? 1 particle. If you say it is a cube, there are 8 corners will be there, and 8 corners will contribute 1 particle. So, there are 8 particles from the 8 corners in a simple cube. Correct, no? So, in a simple cubic unit cell, there are 8 corners in a cube. So, there are 1 atoms at the each center of the cube. Since each 8 corners are equally shared with the 8 other unit cell, so that the corner atom will contribute 1/8 of the each unit cell, so that number of atom per unit cell in a simple cube is obtained by 8 into 1/8. So, it will get cancel. You will get a 1 atom. So how many atoms will be there in the simple cube? There are only one atom, and remember there are 8 corners will be there. 8 corners will contribute one atom or one particle. Each particles will share between the other 8 corner atom. Hence it is cancelled with the 8 and 8. You will get a 1 atoms. That is in a simple cube. We'll see with the body center cubic unit cell also. So here again there are 8 corners will be there. You can see that there are 8 corners will be there. 8 corners will contribute how many particle? 8 corner particle. Each 8 corner particle will share its 8 corners with the other 8 cubic unit cell. In addition to this, we can see that we have the particle at the center. Is it right? Yes. How to write the calculation part? We'll see now. Okay. In body centered cubic unit cell, there are 8 atoms at each corner position and one of its atoms at the center. As each atoms at the corner will contribute 1/8 to the each corner unit cell, the contribution of those 8 corner atom per unit cell is 1 atom, so that the atom at the center of the unit cell is not shared at any of the other unit cell. If you see that the particle which is center or the atom which is center, which is present at the center, is not shared between any other atom. Since it has been present at the center, we need to count it. So there are 8 corners will be there. 8 corner will share with the 1/8, so that 8 and 8 will be get cancelled. So there are only 1 atom will be there. Since we have one more atoms at the center, it is not shared with any other particles or any other atom. So the number of particles per unit cell in BCC is 2. Okay. This is how you need to write the 3 steps to show that how the number of particles will be distributed in a simple cube, BCC as well as in a FCC. Okay. We'll see with the FCC now, that is in a face-centered cubic unit cell. Again, you can see that this is a simple cube. So you can see that there are 8 corner particles will be there. Each 8 corner particles will contribute how many particles? 1/8. Correct, no? So it is 8 into 1/8. So it is 1. In addition to the 8 corner particle, you can see that the particles which is also present at each faces. Correct, no? So how many faces will be there? 1, 2, 3, 4, 5, 6. So it is 6 into 2. So 2 ones are 2 3s are. So 3. So it is 1 plus 3 is equal to 4. Why, ma'am, it is 4? Because you can see that the particles which is present in the faces which has been shared between the 2 faces. Correct, no? So that is why I have written 6 faces into 1/2. So it is 3. So 1 plus 3 it is nothing but a 4. Okay. This is how you need to write the 3 steps by showing that how many corner particles will be there, how many corner atom will share the how many particles to the each unit cell, and also if any center which is there at the center or at the face center, how many extra particles which is there that you need to show it. Finally, you need to count the total number of particles per unit cell. Okay. Next, we'll see with the 3-mark question. So, hope you understood that how the 2-mark questions will be arises. One is differences. One is we can expect the density numerical, and also we can expect the calculation of number of particles per unit cell. Remember, why I am stressing for 2 marks is in the 5-mark again the questions will be split into 3 plus 2. So if I discuss with the 3-mark question, so you will worry about the 2 marks again. So don't worry much, because in the 5-mark, so the 2-mark question will always come from the density numerical. So just now we have discussed that how to solve the density numerical just by putting the density formula and applying the remaining data which has been given from the numericals only. So hope you all understood. We'll see with the 3-mark question how they will ask. So Hope you know that in the 3 marks, always the packing efficiency derivations will be asked. We'll see how to write it once again. Okay. So, calculate the packing efficiency in a simple cube. Okay. So, if I say it is a simple cube, so we know that there are 8 corners will be there. Correct, no? So, these are the 2 corner particles which have considered. We'll see how to derive the equation. Okay. So, where the A is the edge length or the sides of the cube, R is the radius of the each particle. You can consider A is the edge length, R is the distance from the center of the nucleus to the outermost surface. Okay. In a simple cube which contains how many atoms? Only 1 atoms. Already we have discussed. Correct now? The volume which is occupied by the space is obtained by the formula 4 by 3 pi r cube. So, what is the volume of the cubic unit cell? It is a A cube. So, it is 2r. So, as we got from the value, so that is the edge length value. So, 2 into r cube, so it will become 8r cube. Now, you need to put the formula for packing efficiency is obtained by volume of the spheres divided by volume of the total volume of the cubic unit cell. Since we are discussing for the simple unit cell, it is the volume of the one sphere divided by volume of the cubic unit cell into 100. So, what is the volume of the one sphere? It is 4 by 3 pi r cube, and volume of the cubic unit cell, it is 8 pi r cube into 100. So, it will be get cancelled, and finally you will get pi by 6 into 100. So, you will get a 52.4. So, how the marks will be distributed here? Up to for writing the values of A, and with the correct proper simple cube if you write, you will get a 1 mark. Okay, where you have to write? So, up to the values of A cube, that is the edge length with a proper diagram. Okay, you will get a 1 mark, and writing the packing efficiency formula, you will get a 1 mark, and remaining substitution with the correct percentage if you write, you will get a 1 mark. Okay, so total it is 3 mark question. We'll see with packing efficiency in the face-centered cubic unit cell. So, hope you know that in a face-centered cubic unit cell, again I have considered the 2 corner particles. In addition to this, I have also considered the particles which is present at a one face, and A is a edge length and R is a distance from the center of the nucleus to the outermost surface. So, you can rewrite it as A is the edge length or sides of the cube and R is the radius of the particle. In order to get the values of the A, here you need to consider the triangle. So, the face diagonal AC I have drawn. You can see that this is a dotted line which I have drawn to show that this is a diagonal and it is always equal to what? B. So, you can write it as AC is equal to B, and this is a diagonal. Okay. And coming into the triangle ABC, you can see that triangle ABC. Okay. Coming into the triangle ABC, we know that AC square which is equal to BC square plus AB square, and we know that AC square which is nothing but what? B square, and also we have considered the BC square which is nothing but a edge length, and this is also edge length, correct now? So, this is as A square and A square. So, BC square is equal to, we can rewrite it as 2A square. If you cancel out the squares, so the values of B will be equal, B is equal to A into root 2. So, let us consider R for the sphere, so that B is equal to 4R. So, if B is equal to 4R, obviously it will become A is equal to 2R, so that the value will become A is equal to 4R divided by root 2, or you can rewrite it as A is equal to 2 into 2R into root 2. Now, we know that the volume of the cube which is obtained by A cube. So, we need to multiply this values of A into whole cube. So, you will write it as 2R square root of 2 whole cube. Now, the volume of the sphere is obtained by 4 by 3 pi r cube. Since we know that it is a face-centered cubic unit cell, how many particles will be there? In addition to the 8 corner particle, we have a particles at each center and it has been shared with the 2 faces. Correct, no? Hence, it is 4 particle into 4 by 3 pi r cube. So, the volume of 4 spheres in a cubic unit cell divided by total volume of the unit cell into 100. So, 4 into 4 by 3 pi r cube divided by 2r into square root of 2 whole cube into 100. And if you simplify this and if you write a percentage, that is 74, you will get a 1 mark. Remember, for writing the formula 1 mark and writing the remaining substitution with a 1 mark and writing the values of a cube. Okay. Up to here with the diagram, you will get a 1 mark. So, totally you will get a 3 marks by writing this derivation. Okay. Next, we will see with the calculations of packing efficiency of body-centered cubic unit cell. Okay. Again, in a body-centered cubic unit cell, we know that in addition to the 8 corner particle, we have the particles at the center. That is why I have considered the particle at the F, particle at the A, and also have considered the particle at the center. Okay. And I have drawn a diagonal that is from A to F, and also have drawn the diagonal from F to D, and it is considered as a B and this is considered as a C. So, A is a edge length, as we all know that. So, this is a edge length and R is the radius of the each particle. So, FD, already I have told you that this is the diagonal and is always equal to B, and this is also a body diagonal. Why it is a body diagonal? Because it is passing through the body center, hence it is a body diagonal and it is equal to AF will be equal to C, whereas FD will be equal to B. Okay. And since if you consider the triangle EFD, correct, EFD, so this triangle if you consider FD square, which is equal to EF square plus ED square. So, we know that again this is a edge length and this is also edge length. So, it is B square is equal to A square plus A square and B square will be equal to 2A square. And in the triangle FAD, if you consider this triangle FA square will be equal to FD square plus AD square, or FD square you can write. So, which is equal to C square, which is equal to A square plus B square, and you can write B square which is as a 2A square as we have obtained just now from the above equation. So, C square is equal to 3A square, or C square is equal to square root of 3A, or you can write C is equal to 4R, or square root of 3A is equal to 4R. Coming into the volume of the unit cell, so it is nothing but a cube. You are square rooting the 4R divided by square root of root 3 has a whole cube, and since we are knowing that it is a volume of the body centered cubic unit cell, there are only 2 particles will be there. So, 2 into 4 by 3 pi r cube. Now, if you write the formula of the packing efficiency, so 2 into 4 by 3 pi r cube divided by 4r root 3 whole cube into 100, and if you simplify this, you will get a 68%. Okay. So, in the 1 mark, in the 2 mark, in the 5 mark, the questions will be arises. Hope you all understood. In the 2 mark, always remember either the differences will be asked or the calculation of number of particle in a FCC, BCC in a simple cube. Okay. Whereas in this 3 mark, always the packing efficiency will be asked. Okay. And this 2 marks will be meant for density numerical. Okay. This is how the questions will be asked from the unit 1, the solid state. Hope you all understood with this unit. I'll come back with the next unit. Till that, take care, be safe. Thank you.